Hi students, it's Carolyn, and if you're listening or watching this, then chances are you missed the very first day of Math 123. So I'm so sorry that you missed. Hopefully you have picked up a packet. I will briefly talk about a few of these things. I know that you are quite capable of reading things for yourself. But this class is Math 123. It's also titled Quantitative Reasoning. And so we're going to be reasoning with numbers, with quantities. So, of course, part of this idea of being mathematically literate is that you have basic math abilities and number sense and can have an idea if an answer is reasonable or not. And the second part is really knowing how to apply it, understanding it in context, so that if you're reading a news article or you're looking at graphs and tables, you have a good understanding of what it actually means. There are numbers and quantities all around us all of the time, and so many times we are manipulated by people because they kind of twist those facts, those numbers, to influence us. And if we are more mathematically literate, we can make better, more informed choices and really understand what's being said and how sometimes the statement is that figures don't lie, but liars figure. Kind of saying like, we can, make those numbers say whatever we want. So just being a better informed person. So in our classroom, we're going to be, you guys know, if you've had me before, that I really give you a lot of practice. We're going to try to do some things and talk about it. We'll have a lot of would you rather, like making a choice and really thinking about. Sometimes there is a clear-cut better choice, and other times there's not. We'll also use spreadsheets to help us look at some of these things. The first math-ish kind of things in your packet. Here is just an example of if I asked you to find the difference between 1/3 and 1/5. And then you see that there are 4 different choices. And if you need more information about why, I will tell you later. But D is by far the best choice. C is close to the answer, but it's not really equivalent because 1 out of 3 isn't just 0.3. And the other 2 are just flat out wrong. So hopefully, if you worked that problem, you got D. And if not, I'll be happy to refresh with you. So as we go on here, you see a couple more examples. And so just in thinking about what kind of things we could respond, so if we just say a lot more students, that's kind of vague, right? If we say there's a difference of 4,264, if someone simply read that, they wouldn't know which campus had more. And so those last 2 are really better choices because they really compare the 2 things. One is an absolute comparison and one is a relative comparison. But they compare, and it's very clearly stated which one we would know which one has more. In number 3, you can read through that, and in this case, since both the dollars and the taxpayers are in millions, we can just use 240 divided by 3, which would be B, that the average cost is about $80 per taxpayer. Notice it is the money divided by the payers, not the payers divided by the money, like in C. And of A, you see that they did divide 240 by 3, but that is not anything about the percentage. So B is your best choice there. As you are writing about quantities, think about being professional. If you were trying to get a job, so text message shorthand, lowercase i's, please no, all right? Actually look for grammar and spelling errors. Avoid vague statements like a lot more, or, so really give numeric values whenever you can. Write so that even someone who's not in our class could get some meaning from your answer. And then, never plagiarize. You've heard that, I'm sure, in your English classes, but don't copy someone else's work or ideas without giving them credit. There will be times we'll work together, and if there's times that you need to use the internet to look up something, then you should be citing your source. And then there's tutoring available at Ivy Tech. Hopefully, if you need help, you will come to me. I am available on Fridays, and I'm sure there'll be times during lunch that if you would need to stay, or before or after school. But if you happen to be in Emily's class during term 2 of 2022, she's going to be taking a trip down to the tutoring center here at the Noblesville campus, and so just so that you are familiar with that if you decide to go on to Ivy Tech. All right, so here we go. We have another graph here, and this shows the percent of all minorities enrolled in state colleges. This data now is about 10 years old, but you will see that Ivy Tech serves 40% of the minorities that are enrolled in state colleges here in Indiana. Those other schools are Indiana University, Purdue University, Indiana University, Purdue University at Indianapolis, Ball State, Indiana State, Vincennes, and University of Southern Indiana. And so remember, horizontal axis is going along like the horizon, so that's where those colleges are listed. So what's represented along the horizontal axis would be colleges, and then along the vertical axis, in fact, I could be more specific and fully address the question, right? Colleges in Indiana are along the horizontal axis. So really kind of including parts of the question in our response, so that again, even if someone didn't see the question, if they just read the answer and they were looking at the graph, it would tell them. And then along the vertical axis, is our percent of all minorities served is along the vertical axis, the y-axis as we're used to calling it. So if you were to add all the percentages represented from the schools, what total percent do you think you should get? Yeah, I would expect we would expect to get 100%. So it's the percent of all minorities enrolled in state colleges. So if Ivy Tech has approximately 40% plus 20-some% at IU plus about 13% at Purdue and so on, if we added all these together, then all of the minorities attending public state colleges would be listed. So state colleges, this does not include private schools. Now, it's a little hard for us to tell exactly what these numbers are, but that's what we would anticipate that we should get, since all of the state colleges are listed there. What conclusions could you draw from this graph? So there are many things that we could draw from this graph, but a couple of those, or an idea or two, we could say that Ivy Tech serves the majority, the majority of minority. Don't know why I like the way that sounds. How about the highest number of minorities among state colleges? Another thing I could say that Ivy Tech serves approximately 40% of the minority students. I could also say Ivy Tech serves more minority students than IU and Purdue combined. And I could add my, say, 40%, then IU and Purdue combined. And I don't know exactly what that is, but I can see that IU is under 25 and Purdue is under 15. So it looks maybe like 24 and 13. Now, this does not say that 40% of Ivy Tech students are minorities. Okay, it's saying of the minorities going to state colleges, about 40% of them are going to Ivy Tech. So if there were 100,000, 40,000 are going to Ivy Tech. Okay, so it's not, please do not misinterpret this as meaning almost half of Ivy Tech students are minority students. That may or may not be the case, but that is not what this chart shows us. So the information, what information is not provided on this graph. So we have no information about the number of minority students. The minority students attending private schools. Or if students attend full-time. Is not, these are all things that are, I guess I should say are not provided. We don't know any of those things. And you could come up with lots more things. We don't know where these minority students, like what, anything about what type of minorities are they. All right, so. All right, on our next page we have a vertical bar chart that shows us enrollment by age group in fall of 2015. Okay, and so we can check out like along the bottom this time is actually where our numbers of students, the enrollment is, and then the different age groups are along the side. Notice that the younger age groups are 19 and younger. Then you have a 5-year age group, 20 to 24, another 5-year age group, 25 to 29. So if we were to add those together, then the 20s would have the highest enrollment. Okay. Then you have your 30s, your 40s, and then it jumps from 50 to 64, so a larger age group there, and then 65 and older. So we could quantitatively compare any two age groups here. We could say something like I just talked about the 20s, right? If we add it together, the two groups in the 20s, I could say that there are more students in their 20s. Okay, and I would add those two together, this one and this one. 39,329 than any other decade. Or if I'm just trying to compare, then we'll say then under 19. So I could subtract those two amounts for the under 19 and say there are this many more in their 20s than under 19. That would probably be even better. We could say there's approximately twice as many students in their 30s than in their 40s. We could say that 50 and older, so 50 and older, so that would include those top two categories. If I added those together, it is about 10% of the 19 and under. So for every 10 students who are 19 and under, there is about one student who is 50 or older. So there's many, many, many sentences we could write. We could simply say there are 6,934 more students in the 19 and younger group than there are the 20 to 24. So let's think about, we don't know too much about our region, but how this bar graph compares with our class. So in class, we would have, we don't have a very big class, but I also have some data just about my classes in general. To see if we kind of fit that same pattern. Please keep in mind that dual credit students across the state are also considered enrolled at Ivy Tech. And so we're an adult high school, so we do have people who are older, but at most high schools, all of those dual credit students would all be counted in that 19 and younger category. So we have a second graph on that same page. This time we have a pie chart. And so in a pie chart typically, this should add up to, it's a good way to show the parts of a whole. And so this is enrollment by ethnicity, so some crossover with minority like we just talked about on the other page. And so remember how I said this does not mean Ivy Tech is 40% minority. In fact, what we see is that approximately 50% is white non-Hispanic. And this is for fall of 2015. And so just a little bit of a comparison there to our other graph and that information. So if we wanted to compare two of these ethnicity categories, we might say the black non-Hispanic is 1% higher than the Hispanic percent of 7%. We could say something like the white non-Hispanic is more than 6 times. There are more than 6 times as many students who are white and non-Hispanic than there are black students. Now, one thing I will say about this chart is I would not put too much credence on any of those comparisons when I'm looking at a chart with a category that says ethnicity unknown for 31% of the people. So while I might say, according to this chart, there's over 6 times as many white non-Hispanic as black non-Hispanic, but what if those ethnicity unknown, what if they're all black non-Hispanic? Or a good portion. How would that change that comparison? What if they're all white? So there's lots of, we have 4% other and then another 31% unknown. So about 1 out of every 3 people, more than 1 out of 3, we really don't have categorized well. So let's, in class, we would also have looked at our ethnicity and how we might answer that question. If we would answer as white non-Hispanic, black non-Hispanic, Hispanic, other, and then as far as the unknown, would that, perhaps those are people who didn't answer the question, who weren't asked the question. Perhaps they enrolled at a time when that was not a question that was asked. All sorts of reasons that could happen. All right, on the following page, we would be, this is something that we talk about in class, and so it's really not something I can try to help you make up, but about thinking about how many pennies would it take to cover one of the walls in the classroom, or how many books would it take to fill the classroom to the ceiling, wall to wall, floor to ceiling. How many pieces of fruit would it take to fill a bathtub? So you might just ponder that and think of how you might be able to go about that, and what kind of assumptions would you have to make. How would you get your estimate? What kind of things would you need to do? All right, now we have some more basic math, and sometimes we haven't had to use this for a while, and so people have forgotten. So if you look here at the top, blow this up just a little bigger. There we go. You probably may be glad for that. So 12 over 15, or 12 fifteenths, 8 tenths, 4 fifths, 8 tenths, 4 to 5, 80%, 36 over 45, or 36 45ths, 800 over 1,000, 40 to 250, 28 over 35. How are all those related? They are all equivalent. Okay, so they are all equivalent. We usually think about fractions being in lowest terms, and so lowest terms we would want to divide by any common factors. And so some of those fractions they're just larger numbers, but they would all reduce to 4 over 5, and then you also have a decimal and percent equivalent of that. And typically I don't see too many people who want to write it this way. I think usually people think of it like this. So if we want to find lowest terms, then we need to divide by as much as we can. Sometimes we might immediately see a pretty large number that can go into both. Other times it may take more than one step. It's okay if it takes more than one step as long as you keep looking at it to see if it could reduce further. So for instance, if I just notice they are both even, then I can divide the top and the bottom by 2. When I'm doing that, really I'm dividing by 2 over 2, which is equal to 1. And that's why that's legal in math. So this would give me 14 over 21. And then hopefully, if I didn't already, when I look at 14 over 21, I might say, yeah, 7. 7 goes into both of those. So now I'm going to divide top and bottom by 7. To get 2 over 3. And 2 and 3 are both prime numbers, so I know that that cannot reduce anymore. So someone else might have looked at that and immediately said, oh, 14 goes into 28 and 14 goes into 42. And if they did, then they would only have one step. They could have just divided the top by 14 to get 2, the bottom by 14 to get 3. But it's okay to use more than one step. Sometimes trying to find the biggest number will drive you crazy and waste a lot of time. So, in number 2, I see a 5 and a 0, so immediately, I think most of us know then we can use 5 to reduce. And that reducing part, like the divide by 5, top and bottom, could be something you just, like, that's just kind of what's happening in your head. So then we have 9 over 12. And then 9 over 12. I know 3 goes into both of those, so it is not finished yet. So I reduce again and get 3 over 4. And then it is in lowest terms. Once again, someone else might have looked at this and recognized that 15 goes into both the top and the bottom. Oops. And then in that case, we still get to 3 over 4, but it's just one step. But if 15 wasn't obvious to you, use 5 and 3. It's not a big deal. So 7 over 13, 7 and 13 are both prime numbers, and so it will not reduce. This is already in lowest terms. So if you look at something really large, like 864,192 over 1,358,016, that would be quite the animal to reduce. That would not be super helpful for us to try to reduce that. It may just be more convenient to put it into a fraction, that fraction into a decimal. All right? If, when you have a decimal, remember that's a fractional part of 1. All right? So you can always find the decimal equivalent by just dividing the numerator by the denominator. So top to bottom when you do that. And so here we can find these again by just doing that. And then this says round to 3 places when necessary, because some of these aren't going to come out nice and neat. So this one is actually 0.66, and we would round that one to 7, right? Because it's actually 6 is repeating forever and ever. Same with 24 divided by 36. 45 over 60. 7 over 13. I do not have, hold on a second. I had made some notes, but I hadn't worked that one out. Because a lot of these, if I reduce them first, I just knew the decimal equivalent. So, 7 over 13, 0.538, or 538 thousandths is how we would read that. 75 over 125, well, which is the same as 3/5, that is 0.6. 16 over 18 would be 0.875. 16 over 18 is also the same as 7/8. All right. So that 4/5 that we saw all those equivalents to at the top, it's equivalent to 8 over 10. And when we read that, 8 over 10, really we should read that as 8/10 with a th at the end. So 8/10, and that's also 8/10. So I'm going to give you a large place value chart because sometimes we will talk about rounding to 3 places, or we might say thousandths or tenths, and so we need to know like what place we're looking for. We do have a few of those things here in this little portion. So we've got our ones, and then that is a decimal point after that 0. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths. Okay, and so like 8 out of 10 would be the same as 80 out of 100, or 800 out of 1,000. Like you could keep adding zeros. It's just making the fraction larger. Or, for instance, most of us are familiar that 1/2 is equal to 0.5. But like half a dollar, we usually write as 50 cents. So all of these are the same. 5/10, 50 hundredths, or 500 thousandths. This would all be the same. Adding the zeros at the end to the right there is not changing anything as far as the value. All right, just about finished up with this first day. Much more fun in class. So I hope you don't have to miss too much, because I know this is probably really boring and dry because you missed our fun activity and getting our data from the class. So if we want to write things as percentages, and we're going to do a lot with percentages, so if we want to write a decimal value as a percent, then we multiply it by 100, because percent means per 100. So if it's a fraction over 100, then the top number is the percent. Okay? So 20 over 100 is 20%. So when we multiply by 100, it moves the decimal point 2 places to the right. So we don't need to grab a calculator to multiply by 100, please. You're more likely to just type something in wrong. So boom, boom, this becomes 86%, because what does that mean? It means 86 hundredths. So 2 over 2,500 could actually say that this is 1 over this. And then I could divide, right? We know how to do that. I could just have divided 2 divided by 2,500, which then I get 0.0008. Yeah, it's tiny, right? Well, think if you put the 8 one spot to the left, that would mean 8 out of 1,000. And this is only 1 out of 1,250. So it has to be smaller than that. So this is the decimal. It's not the percent yet. So then to change this to a percent, it moves 2 places. So this would be equal to 0.08%. And then our directions say to round to the nearest tenth of a percent. So if it's 0.08, that's actually 8/100ths of a percent. So this would be the same as approximately, to round it, would be 0.1%. Or I could say 0.1%. For number 13, 25 over 20. So there's a couple ways I can do this. I can do 25 divided by 20 and get 1.25. That's a decimal. Then move it 2 places to make it a percent. Right? There's one way. I can also make an equivalent fraction since the 20 goes into 100 times 5, right? So if this is times 5, this is times 5. So 25 times 5 is 125. So 125 over 100 is 125%. Notice that if your numerator, your top number, is bigger than your bottom number, it's going to be over 100%. And here we had our decimal. Round it to 3 places, which works out handy for changing to a percent and rounding to the nearest tenth of a percent. So tenth of a percent means you're keeping 1 decimal place past the whole percent after you move it. And zoom zoom, 9.5%. All right. Oh, hello. Sorry about that. Got a little crazy there, a little cray-cray. So, percents are pretty important, but sometimes we will see things per 10 or even per 1,000. So if we want to change these fractions, this first row, change them so that they say something over 10. So then what would I have to do to go from 100 to 10? I would have to divide by 10, so I'd also have to divide the top by 10. So that would be 2 over 10. This one's a little trickier. So if I want this to be a 10, I could use cross multiply and divide, right? I could use a proportion. I could also think, like, what do I have to multiply this? So to find that number, I would do 10 divided by 8 and get that it's times 1.25, and this is also times 1.25, so this would be 3.75 out of 10. And some of you may know that 0.125, 125 thousandths is 1/8, and so that might not have been much of a stretch for you. So we know that 79 hundredths, just like I just said it, means 79 over 100. So if I wanted to make that over 10, I would move it one place to the left because I'm going to divide by 10. So just like when we multiply by 10, it moves it two places right. Well, for percents, sorry. Multiply by 10 moves to the right. Divide by 10 moves to the left. And depending on the power of 10, if it's 100, power of 10 is 2, it's two places. In this case, only one place. Alright, so now we want to find these per thousand. So it might not be obvious to you that that goes in 40 times, but we all know that 25 times 4 is 100, right? And we all know that because of money, right? 4 quarters is $1. And then if I wanted to change that to over 1,000, if I add a 0 to the bottom, I add a 0 to the top, because that's what happens when we multiply by 10. So 3 decimal places is actually thousandths. So this is an easy peasy one. This is the same as 321 thousandths. That's actually how we should read that. And then 3 over 2 so this would be, I could think that's times 500, so times 500, which would be 1,500. That's one way. I could also do 3 over 2, divide it to get 1.5, and then that's 15 over 10, and then I need 2 more zeros, so 1,500 over 1,000. A little check if you start doing those things and then you're not certain. Remember that 3 over 2, the numerator was larger than the denominator, so we want to be sure that that is still the case. All right, thanks. I hope to see you in class soon.